Hi guys, Barnyard here from freefaucet.io, and today we're going to be talking about Monero, and in particularly how Monero uses ring-CT to keep its users anonymous and private, as well as keeping the transactions of all its users private and confidential as well. So if you're new to the channel, make sure to leave a like and subscribe to this video, and let me know in the comments what you think of this video and also what you'd like me to talk about in the future. So the first thing we're going to do is we're going to talk about the original implementation of ring signatures and ring-CT in the Cryptonote algorithm, and then later in the video we're going to talk about how Monero re-implemented these algorithms to suit anonymous transactions, but also privatizing the amount that a person is sending in each transaction. So how does ring-CT differ from other approaches to sending cryptocurrency privately? Well, if you remember from the Bitcoin protocol, essentially the way that works is you have a user and they use their public key when sending cryptocurrency to another user to prove that they are allowed to send this cryptocurrency and they have ownership of that cryptocurrency. Cryptonote went further with this idea and made transactions part of a ring signature, which meant that essentially users weren't able to see from the outside which of the signatures is needed to validate a certain transaction. So the idea behind that is to have the actual public key hidden amongst a group of other public keys, and all of those public keys have assigned the same amount of cryptocurrency as the transaction that you're sending. So from the outside, it's impossible to know which one of these public keys is actually linked to the transaction that you're sending. So ring signatures or ring-CT has actually been around since about 2001, but Cryptonote had to modify this slightly so that users couldn't double spend their cryptocurrency on the blockchain. And the way that they did this was basically they made it so the blockchain would notice if a user signed two transactions with the same public key. The reason that they don't allow people to use the same public key twice is so that they don't double spend. And essentially that means that they have a certain amount of coins and then they spend them twice. Obviously we don't want that happening on the blockchain. So Cryptonote modified the ring-CT protocol in that way so that you couldn't use the same public key twice and you couldn't sign two transactions with the same public key. There are other ways that you can anonymize transactions by using something like CoinJoin, but the problem with CoinJoin, and I'll leave in the description a few papers and things like that so you can learn more about it, is that you often need a centralized server where these coin mixings are happening. And obviously on a decentralized blockchain, the last thing we want is to centralize things by having a centralized mixing server. So the way that CoinJoin works is essentially transactions are added together by a trusted service so that users can't actually see from outside where all of these coins are going, where they're coming from, and where they're going to. But obviously having a centralized service that you need to trust to join these transactions correctly is going to be a problem when you're really wanting to have a decentralized application that is as trustless as possible. So the thing about ring-CT that's better than something like CoinJoin is that a user can make one of these ring-CTs with their public key at any point, and they don't actually have to rely on a trusted server that is centralized to join all of these transactions together, which means that it's going to be more secure and also keep them more anonymous. One issue with the original Cryptonote protocol for ring-CT is that essentially you could work out with a bit of blockchain analysis, you could really narrow down where coins are being sent to by analyzing all of the transactions where you know exactly how much is being sent and approximately what time it's being sent. So let's say that a user is sending 3 coins. You could really narrow down the addresses of that user by working out on the blockchain which transactions are filled with 3 coins. And you can really narrow down where all of these transactions are coming from, because there won't be a whole bunch of transactions at a certain time with a certain amount of coins. This is somewhat negated because on the Cryptonote protocol, people only used one-time keys, and the sender could include multiple change addresses in a transaction as well. But still, even with all these techniques, there's a big downside to using this because it generates a lot of dust transactions on the blockchain and causes a lot of congestion on the network. So let's say that you have all of these transactions that are really not worth that much. It's boosting up the transaction cost of all the other transactions that might be worth a lot more, and that is a problem on this protocol. Another downside with the original Cryptonote ring-CT implementation is that transactions that were grouped together using ring-CT had to have the same amount of cryptocurrency in them. So let's say that you wanted to send a lot of cryptocurrency. Well, you might not actually have that many pairs and options for you to pair in a ring-CT. So that means that you have less choices and reduce the anonymity again. So it seems that a lot of the problems with the original Cryptonote algorithm is that users outside of these transactions were actually able to see how much is being transacted in these transactions. So if there was a way that you could somehow hide how much people are transacting on the blockchain, that would make all of this process a lot more secure. And that's actually what Monero did. So on the Monero blockchain, it's impossible for anyone outside of these transactions to know how much is being sent. Okay, so now let's actually go into the technicalities of Monero Ring CT, and just try to bear with me. It does get pretty spicy. Things are going to get pretty technical, but it all kind of wraps itself up at the end. And leave in the comments if anything doesn't make sense, and I'll try to clarify it in the comments afterwards. So in order to use Ring CT in a way that coins are not double spent, the Monero developers had to change the LSAG implementation and create a new implementation called the MLSAG implementation, a multi-layered linkable spontaneous anonymous group signature, which allows confidential transactions to be linked together using Ring CT. And this is done in such a way that you can use multiple inputs and outputs, anonymity is preserved, and also double spending is prevented. So how does multi-layered, linkable, spontaneous, anonymous group signatures work? So let's define a few things. First of all, we need to define something called a key vector, which is just a group of key pairs of public keys and private keys. The ring signatures that are used in Monero are generally based off the Cryptonote protocol and their implementation of traceable ring signatures. The use of this MLSAG, as I'm going to call it from now on, is to prove that one of the members of this ring chain with their key pair actually has the secret to their public key and therefore is allowed to spend the cryptocurrency in this transaction. The MLSAG algorithm also makes sure that this key pair isn't used in any other transactions, otherwise we are risking a double spend and this transaction is then discarded. And the way that it does this is having a key image generated from each output that's being spent, which is a cryptographic key that proves that the output itself hasn't been spent before. So this key image can't be used more than once, and it's purely there to prove that this output hasn't been spent more than once and to stop double spending from occurring. So I really hope you enjoyed this video and found it educational. I know it got pretty technical there at the end. Please leave a like and subscribe if you did enjoy this content, because we're going to be releasing a lot more content like this in the future. And if you would like to get your hands on some free Monero, you can do that 3 times a day by visiting freefaucet.io. So once again, thank you very much for watching, and I'll see you in the next one.